So in this question here, I want to use matrix multiplication to show that an anti-clockwise rotation about the origin of 90 degrees, followed by a reflection in the line y equals x, is equivalent to a reflection in the x-axis. So let's just draw one example up on a graph. Let's say I'll pick the point 2, 3. So x is 2, y equals 3. A reflection in the x-axis would just bring this point down to here. That's my x-axis. Reflect it in that, and I will now have 2 minus 3. So basically that would what happen with a reflection in the x-axis. Now if I do a rotation about 90 degrees, if I just draw a line, a 90-degree rotation with the same length line should give me something around about here. So this will bring me to x is minus 3 and y equals 2. So that's minus 3, 2 there. And then I want to do is to reflect it in the line y equals x. So if I then reflect it in this line here, y equals x, just missed the origin a little bit, but that's fine. So if I reflect that in that line, that will bring me to my 2 minus 3. So now I need to show that we're using matrices. So my anti-clockwise rotation, about 0, 0 of 90 degrees. To do that in a matrices, I have the matrix 0, 1, 1, 0. That will show me that anti-clockwise rotation of 90 degrees about the origin. A reflection in the y-axis, so reflection y equals x. My matrix for that one is 0, minus 1, 1, 0. So that would take care of that. And then a reflection in my x-axis, that one as a matrix is 1, 0, 0, minus 1. Okay, so that's my ground values for my matrices. Now what I want to do is to show that doing these two will be the same as that. So these two together will be the same as that. Well, the way to do that is to multiply my matrices together. Now when multiplying two matrices, it's very important to get them the right way around. They're not commutative. So AB is not necessarily the same as BA. If it is the same, that's just purely by chance. So we need to multiply these the correct way around. So as this is done first, followed by this, we write this one first. So 0, 1, 1, 0, and 0 minus 1, 1, 0. And if we multiply these together, hopefully we will get this. So now we need to do something called the dot product when we're multiplying these matrices. So first of all, with this row, we multiply each element individually with each element of this column. So we've got 0 times 0 plus 1 times 1. So that's going to give me 1. So that's my first point. So that's looking good so far. Then for this point, I need to do this row with this column. So 0 times minus 1 and 1 times 0, well they're both 0, so adding together is still going to be 0. So that's looking good. Now for this point here, I want this bottom row with this first column. So 1 times 0 and 0 times 1, both 0. So that's also good. And it's matching what we should have here. And then for the final point, we want this bottom row with this far column. So 1 times minus 1 is minus 1, and 0, 0 is 0. So then, as hoped, we've got the correct matrix representation. Now let's just use this matrix here on our point 2, 3 and see if that gives us that. So again, writing these in the correct order, I've now got my x and y, which is 2 and 3. So let's do our dot product on this one. So as I've got a 2 by 2 followed by a 2 and 1, my matrix will always give me the same value as this one. So the same coordinates. So 1 times 2 is 2, 0 times 3 is 0, so it gives me a 2. So that's matching. And then I've got 0 times 2 is 0, minus 1 times 3 is minus 3. And we've just shown there that we've got the same points on our graph, and that matrix multiplication there has also given us the correct result for a reflection in the x-axis. Okay.